We're about to get started. Actually, let's get started promptly. I think we have a quorum. Welcome, everybody, to the second Sandbox Punch bi-monthly meeting. We're really excited to share some more punch data with you and to give you some tools so that you can play with the punch data yourselves. We're going to go, we have a lot packed into 2 hours, so I'm going to get started right away by handing off to the punch PI, Craig DeForest, who's going to give us a mission update.
All right, let's see. I will share my screen. Sent. And all right, can you all see my slides? Excellent.
Yes.
So, okay, this is day 223. This is day 232. Sorry for the typo on the first slide there. We have been in flight since March 11th. And there's a lot going on in the mission, and we are excited about it. So let's see. You've all seen this before, but I have to show the slide just in case. So remember, Punch is 4 spacecraft that are orbiting on the dawn-dusk line. We are acting as one virtual imager, and you'll see a lot of progress toward that direction today. We started our science operations in early June. We've been in our nominal constellation configuration with the WIFIs 120 degrees apart since early August. Status, everybody's working fine. We had a single event upset in NIFI just the other day, but it recovered just fine. Data are flowing. We are making preliminary data right now. We have an issue with stray light in NIFI. I'll give you an update on that. And we have just updated to version 0H. So you're going to be hearing a lot about that during these intro talks. So science, just a reminder of what we're doing. We have these 6 major science questions, which are organized into 2 separate objectives. The first is the ambient solar wind. We have 3 working groups working on aspects of that, led by Barbara Thompson and Raphael Atier is the global and evolving solar wind flow. Looking at the Alphane zone, the boundary of the heliosphere and corona. That's Steve Cranmer and Rohit Chibber in working group 2. That's 1C. And working group 1B is Nikki Weil working on solar wind microstructures and turbulence. Clearly, I hadn't had enough coffee when I put these slides together. All right. So the working group 2, A, B, and C is on transients. We have Anna Malonushenko and David Webb working on 2A. These are the leaders of the groups. Working group 2, Bravo B is Kirk Koenig working on stream interaction regions. This is an old slide, so it says CIR, but remember we're deprecating that and saying SIR whenever possible now. So working group 2C, Charlie is Heather Elliott and Mihir Desai leading, looking at shock dynamics. And we expect to observe shocks as they form and propagate in the heliosphere. So instruments, just a reminder, we have 2 different kinds of instrument. The reason we have them is the huge dynamic range across our field of view. The dynamic range is also driving the precision of our calibration. And so these 3 orders of magnitude in the WIFI field of view in particular, between the brightest thing that we see on the sky and the actual signal we want, that's driving the precision of our photometry. And we're hoping, of course, to get 4 orders of magnitude, but we require 3 right now in our photometric precision. We're not quite there yet, but we're close. These are the 2 kinds of instrument, NIFI and WIFI. And this is a slide that you've mostly seen before, just showing what the kinds of data are and how the trefoil fits together. What's available right now is we're making full field of view trefoil mosaics minus NIFI because of the NIFI stray light issue that's going on. We will eventually merge NIFI into those data products, but we're not quite there yet. We have moved WIFI a little closer to the sun to account for that. So we actually are getting in as close as 12 solar radii with the WIFI images. The mosaics you're seeing will have a triangular hole in the middle where we eventually will put NIFI. We are making forecast quality mosaics. The mosaics themselves don't include NIFI, but we are making NIFI data products, and I'll show you some examples of those in. But the NIFI stuff and really the mosaics for Quick Punch are forecast quality. They're really aimed at capturing the morphology of CMEs as they leave. So this is one of our early movies. This is from late May. You're going to see something comparable now, except not with one-off processing, but with pipeline processing. So we're very excited about that. So we've tracked several HALO CMEs. We're writing up tracking results from that first one. There are several other papers I know of in progress right now. This movie was made early in the mission. Sam Van Kooten, who's here in the room with me, made this using special processing, not part of the pipeline, just as a one-off to try and optimize. We can't do that for every single event, of course. The pipeline needs to be able to do this kind of reduction automatically. We have now achieved that. So you'll see that in a moment. The links, of course, are here. I have to put the web page link up just in case there's somebody who hasn't been to all of our prior meetings. We're doing all kinds of other interesting things with Punch. This is Comet Swan that was discovered on the 11th of September. Turns out it was in the Punch field of view from early August on. And so this is a tracked movie using an earlier version. This is 0E style processing, just showing Comet Swan plunging in from the outer solar system even before it was discovered. This is the day it was discovered, the 11th. That's Spica and Mars in the background. We're just tracking it across the field of view, and you're seeing boundaries go by. Shortly after we pass Mars, you'll see here, there's another comet crossing the other way. That is 3I Atlas, which we're also tracking. And so it turns out we're pretty sensitive to comets. This movie that you're seeing now, I'm showing it, is the longest high cadence track of a comet ever. It's 50 continuous days of observation. So we're pretty excited about that. And if you're sharp-eyed, you'll see that the tail is waving around in the solar wind. It shows disconnection events, much like the Encke analyses we did earlier. That's pretty exciting. The comet everyone's talking about right now, other than Atlas, is Lemon, which is very bright and observable with binoculars in the western sky right around sunset. It's also in our field of view, and you can see this is just another sort of preliminary track using that same 0E style processing. But it should be much clearer in the H data that are being generated right now. So Punch is working. This is back to that early HALO CME that we saw at the end of May. But the spacecraft are healthy. We're getting ready to maneuver them in late November just to maintain the constellation spacing. We're also getting ready for our first nonlinear calibration. We'll use a couple of 8-minute windows from each Wi-Fi to generate a nonlinear scan and see if the detectors are evolving in their nonlinear response to light. We have eclipse season coming up. So the spacecraft will be flying through Earth's shadow starting around 6 November, so just in about a week. You shouldn't see any difference really in the Wi-Fi data. Stray light from the sun will go away when we're in shadow, but because we don't use the sun for pointing, we have to actually tell the spacecraft the solar ephemeris. The Wi-Fis will just keep observing. The Earth will never enter their field of view, and we should just receive normal data from them. That will verify the amount of stray light by looking at those data. NIFI will see the Earth, and so we're going to be preparing movies of the Earth going through, and we're hoping to further get a handle on the stray light within NIFI using this data. So refinement continues. The Gulf data that you may have been looking at has about 7% relative photometry. That is to say, the photometric sensitivity across Wi-Fi varies by about 7%. The H is 1 to 2%, and you'll see the results of that today. That allows our routine data products to achieve the quality that we pulled out of the hat the special processing at the end of May, June. Version 0i in about 2 weeks, I expect to get down to about 0.3%. So another factor of 3 in photometric quality. We're getting improved alignment. Sam may be showing you, Marcus may be showing you that. The seams, we're no longer doubling stars, and it's just getting better. Cosmic ray removal is coming in. We've made strides in how to do polarized background removal. And of course, we have better VSO access now, so FIDO works right. And we're continuing to improve the documentation as we roll out releases. So all this is going on now. Very happy about that. This is current NIFI data, or for the current event. This NIFI is subject to stray light from the Earth nearby it, which illuminates the interior of the baffle tube that scatters off of the rear of the occulter, and the variable pattern swamps the corona. We're right now using this preliminary PCA, principal component analysis based processing that Sam came up with over the summer. We are working on improved reduction that will take out, we hope, all of this and allow NIFI to meet its photometric requirements. We don't know if we'll get all the way there, but we will get to much better than this. So NIFI is working fine. We got the stray light problem. The quick punch data that we're making, this is straight out of the quick punch pipeline. They do have the full resolution CNN product, which is a NIFI product. We're not merging NIFI into the mosaics right now because it's too distracting. But as soon as we drill a little bit farther in, we'll start merging it with the regular mosaic products. We are operating with the 8 solar radii closer to the sun than nominal, so in at 12 solar radii, just to be able to capture more of this field of view even with the constellation. So meetings, save the date, Punch 7. I think you've seen announcements for that May 12 to 14. That'll be right here at Southwest in Boulder. By that time, that's 6 months from now, we expect lots of great science with these new data we're rolling out. Our next Bimonthly won't be a telecon at all. It'll be an in-person meeting on the 18th of December in New Orleans. There's some other meeting going on at that time, but you'll see announcements for the specific location, which is La Papillon Hotel, coming from Sarah over the next couple of weeks. Let's see. So special collection papers mostly are done. I have to shake my finger at the people who haven't gotten theirs in yet. But we expect all of those to be in the next couple of months. Meanwhile, the description paper is there. Please do cite that instead of the 22 paper. We've been citing a 22 conference proceedings for the punch description. I'd much prefer that people use this 25 paper, which is more complete. Punch is funded through the end of 26, so even though the government is in shutdown, we are operating normally, and your funding should be flowing from Southwest if you're on a subcontract. The data, of course, are also flowing, so please don't stop just because the government did. So I'll close with a quote from William Mulholland. He said this as he opened up the taps on the aqueduct into Los Angeles, which made Los Angeles what it is today. So there it is. Take it. And back to you, sir.
Actually, can you pass it to Marcus? Oh,
Marcus.
hang on. Let's make Marcus a co-host. So oh no, actually, Marcus, you don't need to be a co-host. Just share your screens.
Okay. You should now be seeing some slides, right? Full screen?
Yeah, we are. Thank
Looks
you.
great.
Hit that. There we go. Okay, so I'm Marcus Hughes. I'm the Science Operations Center lead. And all the work you see in these next few slides is the product of the entire SOC and Craig and the science team and everybody. So I just want to say thank you for everyone working so hard. So let's start with a file name. It's not the most glorious thing, but I promise we'll get to some movies. So a file name is helpful to identify what image you're looking at. So it's composed of first the punch, and then L3CIM is a product code, and we'll talk about a list of those. The date of observation, so this is year, month, day, hour, minute, and so forth. And then we have a version code. So we'll talk about how the version scheme works briefly as well. And then we'll look at some data. So this is one product code that you might explore and use today. So the data product codes are composed of the level and then a little code. So this is level 3, so L3, and then CIM stands for Clear Intermediate Mosaic. And if you go to our website, I'll show you how to do that in just a second. But if you go to our website, you'll see that there is a long list of data product codes under a data tab. And so all the product codes are described. And if you look closely, you'll see there's actually a pattern like PTM and CTM. So that's just the polarized version and the clear version of the same thing. But in general, as long as you match up the code and the level, you can get to the description of what that product actually is. So the full product code list is in the punch bowl documentation, which I'll show you. In addition to the product code, you need to know about the versioning. So our versioning scheme is a number followed by a letter. So the number, all of these go in lexicographic order. So we start with a number. Right now we're in version 0. And then we have this letter for kind of a minor iteration that we're doing. So when we get to version 1, everything will be fully processed for all the data products. But right now we're on version 0, so it's preliminary data. And then G or H indicates that there have been so many minor versions before. And if you look on the website, once again, there are data version notes that tell you what's changed between each version. So how do you get to the website? If you go to GitHub, I should have put a link on here, I realize now. GitHub.com/punch-mission. You will land on a web page that you can go to Punchbowl, or you could just go directly to the link over here on the right. So if you say punchbowl.readthedocs.io, I don't think you even have to put that extra stuff at the end. It'll direct you to the documentation website. If you have questions, please open an issue or open a discussion on the Punchbowl repository. Don't hesitate if you think that maybe you're opening in the wrong spot or you think it's not a pertinent question. Like, every question is relevant, and we'd like to receive them so that we know how to clarify things and make our data products better. So let's look at some data. So this is version 0H that we've been talking about. So this is the August 30th event. And this is the level 3 CIM images. So we started with that product code. So this is a compilation. Oh, it's doing fun things. I don't know why the video is now rendering weird, but it's a compilation of the level 3 CIM images with image persistence. So it has the trefoils, and then we're just keeping around the most recent trefoil as we go around. These videos will be available to you. So even though it's for some reason stuttering right now, you should be able to get them. So let's talk about the things that are different between G and H. So in version G, you could see these ugly seams between the different Wi-Fi imagers. And so those are now greatly improved in version H and practically non-existent in this F-chrono subtracted image. There are other artifacts that you can still see. Sometimes stars are not perfectly circular in the way they should be, but we're continuing to work in improvement. So G to H is a great step, I would say. So if you're looking to use which data, always go for the H now. Always go for the latest. Another improvement that we made is on the G version, you could see that there were these banding artifacts. So this was because of the square root decoding procedure that we do. On orbit, we square root encode all the images, so that way they downlink in a smaller format. But when we were decoding, we weren't fully accounting for all the noise properties. And so it was leaving this kind of banding image in, and now that's greatly improved. Another thing you can see here is the stars have these little tails. So we've known about that, and we've been working on improving the coma from the instrument in software. And so that model has been updated, and it's much cleaner. There aren't as many artifacts from the point spread function. And then finally, this is a view of just a single trefoil, the whole thing. You can see all the artifacts we've talked about so far, like the banding up here is gone, the seams are better. But then another thing you can notice is right here, I think you can see my cursor, this object had a huge saturation spike. So we're handling saturation better now as well. And the F-chrono, I think, is removed a little cleaner. So there have been lots of iterations in this new version. So we want you to start using it. Here I'm showing the same movie I had a moment ago, but I've suppressed the star field some. So that's something you can start experimenting with the data and how to make it cleaner. There will be a star field removed version coming, a product that doesn't have the star field in it, but that's not quite out yet. So let's just watch for a second. Here you see the CME, and you can track it pretty far out. I don't know if I can see it all the way to the edge, but we're going to keep working on that so that you can have better sensitivity. So what's coming next? We've talked about this version 0H. It's available now for the August 30th event. That data should be available on the SDAC. We're going to get the rest of the products, the rest of the images processed, and we're going to also start running it live for all data going forward very soon. And as we've talked about, there's saturation artifacts that are suppressed. I didn't show you, but the polarization background should be improved. The vignetting models result in a more seamless image. And the point spread functions have been cleaned up. What else is coming? We're going to have cosmic ray reduction in the next iteration, next version of the data. The star field we subtracted in a coming version, so that'll be the new codes for CTM and PTM and level 3. Low noise images will be generated for level 3, the CAM and PAM codes. We're going to continue to improve our F-chrono removal, our distortion model, so that way we don't have pointing errors. We're going to work on the nonlinearity in the images. And then eventually, NIFI, once we've handled the dynamic stray light, will be included back into the mosaics. So I just want to take a quick second. You're going to play with the data, and you're going to have some software, some code available to you to get images. But I just wanted to show you that it's pretty straightforward to grab punch data at this point. So this is some Python code. You only have to change these two lines here to get the images you want. So a start time and an end time. So here I'm just asking for a recent image. You give it a product code from that list on the website, a version that you want, 0G, and then the rest of this can stay the same. It'll search through the using Fido from SunPy and get data from the VSO and the SDAC. And so all we're doing here is we're doing the Fido search, and then it doesn't have search parameters for everything we're looking for. So we just look at that file ID that we saw at the very beginning, the file name, and make sure that the components of this product code and the version are actually present. And then we download the data. So that's all I wanted to say today. We're going to end with this movie that Sam Van Kooten made where we included NIFI in the August 30th event with some starfield suppression. And then importantly on the right side, if you have questions, please go to this github.com/punchmission, or if you have a question that you think is better answered with one-on-one communication, you can email us at punch_soc@square.org. So thank you, and I'm excited to see what we can do with all this data.
Thank you, Marcus. Okay, we're going to go right along the next part of our meeting. Please put questions in the chat. So I wanted to announce here that we're going to have a new topical working group. Craig talked about our science working groups, which are part of the programmatic punch mission with our COI, but we have a completely open to the community topical working groups. And the one that's we're launching, and Barbara Thompson, who could not be here, is going to be leading that. And it's going to be called Coordinated Analysis of Punch Events. And what we're talking about today is an example of the kind of thing you can do. But there'll be more information sent to the Punch Science mailing list. You're probably all on that, but if you're not, you can go to punchhelp@mailman, Boulder, Swery, Edu, and we'll add you. So the the event that we chose was one right around the end of August. We wanted to make sure to use a case where we had the full trefoil in position. So we wanted to choose a first case to study after we had the telescopes all in position, which we did. And here are some of those punch movies again. And I think you've seen them already, but what we're looking at is a HALO CME, and you can see that there is, run it one more time, actually activity in the day before it, and we'll come back to that because there's one that started around 20 UT on the 30th, but there were actually some HALO events right before that as well. But this is the primary one that we've been looking at. There's another one. This is the same movie except with the constellations, sorry, with the constellations in the background, so you see just how big of a field of view we're looking at. Okay. And then here is, and by the way, all of these movies are going to be available to you in this slide deck, which we will send to Punch Science how to get it. So here we go again with the zoom in of the NIFI field of view and that coming out through NIFI and into the WIFI field of view. At this stage, I'd like to hand off to Annie. I believe I'm handing off to you, but I will drive the slide, so just tell me when to advance. And she's going to talk a little bit about the early stages, and thanks to everybody who contributed.
Sounds good. Can you hear me okay? Yes, so there are two text slides that I'm not going to spend much time on, but they are for later on for the recording of this meeting that give the timestamps and the details of what exactly was seen in the SDO, in LASCO, in stereo. And on the click on the next slide, Sarah, go to the next slide, please. Okay, and yeah, the stereo A and the PSP. So I would like to focus on the movies here now. So should I say click, Sarah? Yay! There we go. So we have a HALO CME that originated very close to the disk center as seen in SDO, and you could see nice HALO in LASCO C2 and C3. Can you play them again, please? Yep. Now the next step is to look at their origins on the sun, and for that I will show some SDO data. Click. So this is the magnetogram, and the reason why I'm showing it is because there are three dipoles that I think are important in analyzing this event. So in the southern hemisphere, there is an let's say dipole 1, P1 and 1, positive and negative, dipole 2, and then dipole 3 is roughly at the equator. Now the large eruption had originated in the third dipole. However, click. If we look at the AAA images, we can see that there's a lot of structure, a lot of connectivity, and there's a backstory in that. Click. So first off, in AAA, you could see that P1 and N2 are connected by coronal loops. Click. Now P2 and N3 are also seen connected by coronal loops. Now, I do not clearly see any loops connection N2 P3 and N1 P3, but honestly, it will not be that far-fetched. Then I do not have a lot of time to go through the details of the movie, so I will just quickly give an overview of what was going on in AIA at that moment. Click. So first we had an M1.3 flare in the dipole 1. Click. Then click. There was an associated brightening almost contemporary close to the second dipole, the positive P2 second dipole. Click. Then there was another M-class flare in the first dipole. Click. After a while, there was a larger flare and eruption in the third dipole, which was the closest to the disk center. Click. That had launched an EUV wave that was best seen in AIA 193 and 211. Click. And then something very interesting. As soon as that wave had reached the northeast limb, you could see another minor eruption taking off at that time. Again, I do not have a good solid proof that it was caused by this wave, but certainly the time is extremely suggestive. The reason why I'm going through all of this is if we analyze the in situ signatures and punch signatures, I wouldn't be surprised if we see a lot of fine structure. So I'm excited to see what's going on. Click. Now I'm going to show you the time difference movie, and that is a difference movie in 211. Now, as soon as you will see the first peak, the first flare, look at around 0 - 20. Yes, so that was the first dipole. Then there was the second flare right over there again. Then after a while, the dipole labeled as P3 and 3 will produce a bigger flare, and you will see it on the light curve and at the Gauss light curve soon. But if you could look at like 0 - 15 on the solar equator, yep, there we go, and the wave, and you just saw the wave, and there was here an eruption at around 40 on the northeast limb. So click. So it does look like there is a complicated structure here, the complicated magnetic structure, and I just cannot help but think about the hypothesis of sympathetic eruptions. For example, see the simulation by Tibor Torok et al. At 2011. So given that there are several more flares involved, I would not be surprised if we will see several more flux ropes that precede the major one. But it is more or less clear that the third dipole is the source of the EV wave, and possibly the source of the halos that we see later on in LASCO. Click. So here's the velocity measured at LASCO C2, C3. Click. And it was also seen on stereo observations. Now, in the bottom right panel, the blue arrow shows where the Earth is, and red arrow shows where stereo A was, which was roughly 40 degrees ahead of Earth, 45 degrees. So there was also a nice stereo image, and yeah, and you can take time difference images, and the upper two panels are stereo high 1 and high 2 difference images. So yeah, click. And the last slide that I want to show is the Enlil run that also shows the simulation of the CME. So that's about all that I have.
That's great. Thank you, Annie. And again, let's put some comments and questions in the chat. I'm going to move on. And our next contribution comes from Chris Mostel, and Tanya Ionosphere is going to be presenting it. Tanya, are you there? I see you, but I don't hear you. Uh-oh.
Tanya, we're not hearing audio from you.
Okay, Tanya, may I suggest that you...
No, can you hear me now? I'm so sorry.
Yeah.
I had to change my headphones, so okay, sorry. Yeah, I just want to briefly show you what we at the Austrian Space Weather Office have done so far on this event. So next slide, please. Our model outputs are mainly based on the donkey parameters related to this CME, and also on heliospheric imager data from stereo A. So in situ at L1, we saw a quite nice example of a northwest-south rotating flux rope. So it's left-handed, and it shows a low inclination, which is corresponding to having its source region on the northern hemisphere. Next slide, please. Stuart Bale provided us with in situ data from Parker Solar Probe that was quite close to the Sun-Earth line. And we had a shock arrival on the 31st of August at around 5 p.m. and a shock arrival at L1 on the 1st of September around 8:30 in the evening. So maybe I should note that the PSP data is only preliminary, so it's not calibrated well yet. And BR and BT are plotted with flipped sign to make them better comparable with the GSM coordinates in which the L1 data is shown. Next slide, please. This is now our ELEVO model that runs in real time on our website. It's drag-based, and it automatically pulls the input parameters of the CMEs from the Donkey database. On the right side of the movie, you see the in situ data at L1 and also detected by stereo A. Next slide, please. Here you see a snapshot when the CME arrived at the PSP spacecraft. And in the model, it was around 1 p.m. on August 31. So that's, I think, 4 hours too early compared to the in situ arrival time. Next slide, please. And that's the snapshot when the CME arrived at L1 in the model. And I think here we had an arrival time difference of 8 hours. So the model predicted the CME to arrive 8 hours earlier than it actually did. Next slide, please. So the next thing we did was to include heliospheric imager observations into our modeling. So stereo, as was already said, is at the moment at a very nice location to observe CMEs that are Earth-directed from a side view. And we trace the CME within a time elongation map. So that's the red crosses you see in the right upper image. And the easiest thing you can do when you have such a time elongation track is to simply fit it with one of the easy high fitting methods. For example, the fixed phi fitting method that assumes for the CME a point-like shape and a constant propagation speed. And using this method gives us an arrival time at L1 on 1st of September at around 12 o'clock. So around the same as our ELEVO model does. Next slide, please. So the next step was then to input this time elongation profile into our ELEVO High modeling tool. And the first step within ELEVO High is to convert this time elongation track into a unit of distance, so into time distance. And this time distance profile is then fitted by an equation of motion that is drag-based. So we call that dBm fitting. And in the right lower figure, you see the first approach of this. Here we used the whole time elongation track as input into ELEVO High. And but unfortunately, we were not able to really match both in situ arrival times, so at PSP and at L1. We matched it at PSP quite well, but at L1, we had a late arrival of about 8 hours. So I tried to only feed half of the track into the model, so up to 34 degrees elongation. And this actually leads to a better arrival time at both spacecraft. Next slide, please. By only using half of the track, we really match both in situ arrival times quite well. So, but keep in mind that the ELEVO prediction is real time and the ELEVO High is not. So you cannot really compare the both predictions or modeling results. So the next step is now for me to use punch elongations to put into ELEVO High. And I'm very excited about that and looking forward to that. Next slide, please. The last model I want to show is our 3D core flux drop fitting model. It fits a gold Hoyle-like flux drop with an elliptical cross section to the in situ data in this plot to the L1 data. And the shaded area corresponds to the 2 sigma spread of the ensemble. In the figure at the lower right corner, you see one example of an ensemble member, and in the table above, you see the fitting results. Next slide, please. That's my last slide. So on device, I have simulated white light and polarized brightness images for this event from, so to say, a punch point of view. And it's done with the same parameters as 3D Core has found, but he increased the aspect ratio to better match the halo appearance in the images. The colors on the right image correspond to the different polarization directions. So all our results are, of course, preliminary and work in progress. That's all from me. Thanks.
Thank you, Tanya. That is excellent. And we cannot wait to see the punch data with your tools. That's going to be fantastic.
Me neither.
All right. Now, I believe Volker is not able to join us. He had a conflict, but he did provide some material for us. If I'm wrong, Volker, and I didn't understand that rightly, please put something in the chat or shout out. Otherwise, I'm going to walk through it really quick. So they have the Discover and KP Quick Look data in near real time. The theta and the phi angles are converted to GSM coordinates, and the solar wind data are again with a few minutes delay. Now, this is the example of the CME event that we've been talking about between the 1st and the 3rd with a shock and an ICME. And we're going to see some more in situ data in just a minute from Heather as well, and Maher, as well as September 6th to 7th. He also was looking at the source, which Annie has covered. And he points out that there were 2 events that they saw, one in that 1st to 3rd date and the other in the 6th to the 7th. And he points out that there is the case at 2009 UT we've been focusing on, but there was also something that left at 0023. And in their simulations, they found that they would have near similar arrival times. And so the question is there 1 or 2 events? And he sent me an email just this morning, which I'm going to read to you, because I think this is interesting. He says, from my point of view, there's a possibility the FluxRope CME, ICME, is from the one that starts this earlier one and not the later one. And the shock of the latter may run into the first. But it's a possibility based on FluxRope polarity and the characteristics of events, which may differ from the main interpretation. And I think his point is made here, which is that this is a great one for Punch to investigate as we continue to improve the Punch data to really see what's catching up with what and to try to localize, for example, in 3D where the front is. And I think that's the main things from Volker. Thank you, Volker, for providing those. And now I'm going to turn it over to Heather Elliott.
Yeah, okay, we can go to the next slide. Maher and myself were looking kind of more at the L1 and the Earth perspective. And so this is that same event. This plot starts on August 30th. It goes through 9/10, and you see that nice shock. And then you see a CME and the cloud. And then there's another event. Looks like there's a CME, and then we may dip into the high-speed wind and then back into a CME. I'm not sure about this, but the second one has a really deep cavity, so that should probably show up as a dark region. And then they've already talked about more of the field perspective too. But there's definitely more than one event. I am interested, since they were talking about that there could be 2 up here on this one to merge together. Yeah, you can see down here there's a nice sheath region, and then there's like a rotation that starts here where the minute cloud is. Yeah. Okay. We can go to the next one. So we've been also thinking about what would be useful in general for trying to identify these events. So we thought that it might be useful to make some longer plots, like keep a running year-to-date plot, and also, or at least a 3-month plot, and then look at the polarity of the solar wind as it comes in. So I've color-coded the polarity of the onto the speed plot. And then you can then start to see when things are co-rotating. So you have a whole group that's looking at the CIRs. And so here I've also flagged high density times and high magnetic field strength times. And you can see there was an earlier event towards the end of May and beginning of June where there was a high-speed stream that repeats, and then the CME is running into the high-speed stream. So that's at the start of June. If you go point your arrow at the start of June, yeah, there's that CME. There's that big red spike there. It's running into a high-speed stream that's blue ahead of it, and then there's another CME as well. So we were thinking we could help out the CIR group by also plotting some of the in situ data in a way that would be meaningful by them, by looking at these long plots where you can really see the co-rotating features. So I thought it might help them. Okay, next slide. Yeah, so this is that same event, and Maher has repeated the solar wind speed. So you see that there's that nice shock toward at the end of I think August 31st, beginning of September 1st, and then there's the CME. And then if you look at the second panel where the iron is, you see that what I've marked as ESP. So when the shock arrives, the energetic and superthermal particles jump up because they've been accelerated by that shock. So you get a spike on that. And so this is where punch can, by looking at the in situ and the punch data, that, you know, the size of the speed jump, how strong the shock is, really affects those ESPs. And so they're not forecasted that well. So that's why we're excited about working with punch and the in situ data. And then you see that there's this second complex event where there's a CME and then maybe a high-speed stream towards the end, like that second event they were talking about. Yeah. So I think there's so you can see the alpha waves on the high-speed stream is that fuzz on the speed plot. But even the second event has some energetic particles associated with it. And then the plot that's on the right kind of zooms in and shows the even higher MEV particles, and you can see that there's this, you know, big boost in the particles at that shock for the ESP. And so this is the kind of thing that we can do. And so figuring out how that shock evolves can really help us forecast the ESPs. And I don't know if I have another slide that might, no, yes, I do. And so, yeah, so we were also kind of trying to look at kind of the space weather effect. So I'm plotting things like the KP index and the DST. And so this event was very mild as far as the geomagnetic indices go. And then I plotted to the right at that earlier event from late May and early June, and it was more geo-effective, but I plotted it so that, see, I'm flagging like the strength of the storm using the criteria that NOAA uses. So I color-coded those to look at the strength of the event. And so when you zoom in, you can really see that high-speed stream that's ahead of that CME that starts at the beginning of June. And then there's another CME later, but it's the first CME looks a little bit stronger storm response. But so we're thinking of, we made these plots for this event as a test case, but we're trying to think of like what we can do on a regular basis to help identify events, at least semi-automatically, so that the team can start really looking at them kind of from beginning to end. And so that's what we've done.
Oh, thank you so
think
much, Heather.
yeah.
That is great. Move on. Do we have Bernie Jackson online?
Yes.
Okay, Bernie, go ahead and why don't you tell us what we've got here?
Okay. Well, we were able, at least in the first event, to put icy and LOFAR data together. There's an interplanetary scintillation data in Gibraltar that is running real-time IPS, and so we were able to combine this with this for the event that was on the earlier view that we were shown. So next slide. And here's a slide of the event in NIFI, and then WIFI, you can see the material out a little farther at a later time, and then later than that, over here on the in the upper right, you can see an image of the structure when it's reached Earth. This is a value of scintillation level, and it's proportional to brightness, more or less. You can see the velocity up to the north here, above the ecliptic plane, and that's a higher velocity at the time the event reached Earth. Now, you can see down the lower left the time series, and I've marked where the event arrived at Earth. It's not a very dominant peak in density, at least not in the ACE data. You also see in the middle what the event looks like in the ecliptic plane. To the left of the orange plot, the right orange plot gives a meridional cut, and you can see the event that's arrived at Earth at the time of the images up in the upper right. There's a map of the velocity. The velocity hasn't gotten too much higher here in the ecliptic. At that time, there was a slight enhancement in velocity before that. And you could see that the largest velocity, the highest speed, went north of the ecliptic plane in the meridional cut in the lower right. Anyway, next slide. We were able to look at the September 2 event, and I kind of go over the first part fast. You can see where GSM-BZ goes negative here. These are GSM-BZ forecast plots, and you could see the sector boundary headed towards Earth in the middle upper left ecliptic cut. The meridional cut shows the high BZ component, and then you can see negative. And this is all co-rotating structure obtained from the magnetic fields on the surface of the sun. So it actually, the co-rotating structure and the boundary can be seen in the lower left time series when the BZ went negative. And there's not a very large negative excursion, but these usually cause a KP index increase if it goes below minus a nanotesla. And in this case, this was our prediction of KP, and it kind of fit, although it came a little late. I'm not. That's kind of what was of interest at this time, because we were able to predict this and see it happening many days in advance, and so you're interested in when the KP is going to change in advance. So we have a machine learning program that does this. The other thing is that over on the right you can see this event, and here's a plot, and I'm not going to make too much of this because it's preliminary. But you can see Earth is over on the right, and you can see the structure that is involved in the CME that's just about to hit Earth at this time at 15 UT. There was a preliminary feature that came by Earth before that. This is a plot all the way out to Mars. And you can see a very dense structure on the west limb that comes out. That's fairly much isolated to the ecliptic plane. And that's there's far more material in the ecliptic plane. The event seen in the meridional cut is more intuitive, or tells you more what's happening. There was a very dense structure that at the time of the arrival of the density that was north of Earth in the ecliptic, north of the ecliptic plane. And there's also material south of that, and there are a bunch of bits linked in this fairly complex event. What's seen at Earth is pretty much not a very dominant feature, at least in density, and that fits too with what's seen in situ. You don't see a very big in situ density, and I've looked at wind data, looked at Celius data, and looked at ACE data, and all three show an event there, but it's just not very dense in the in situ plots. So the main thing is the feature's very structured. And what you see, of course, in the ecliptic cut is the material pretty much arrived at Earth first, and then came back second at stereo, with this very large density cut that preceded this by a long ways, present along the ecliptic plane. Anyway, that's what the interpretation is from the interplanetary scintillation data here at this time. Thanks. That's all I have.
Thank you, Bernie. That's very interesting. You're starting to get a nice picture pulled together here. Shaheda Sheikh, are you online, Shahi?
Yes, Sarah, I'm here.
Okay, go ahead. Why don't you show us your slides?
Yes, thank you. I'm here to show about the heliospheric imaging perspective of this event using Whisper. Unfortunately, Solo High onboard Solar Orbiter couldn't observe this event. Otherwise, it will be an additional viewpoint to do more of CME analysis. So on the slide, what I have is the snapshots of a very preliminary Whisper image. Where you can see the inner detector has the field of view of 26 solar radii to almost 105 solar radii. And on August 30, if you see on the top, right top plot, the purple is where Parker was, almost close to the Sunnet line. If you see in the images, it's kind of very faint, but I can compare that with the LASCO image, how it looks like in the next slide. But now, if you see that with the orange arrows that I pointed out, so in the beginning, it looks like more of a flux rope kind of structure, and later it becomes a flatter front. And it looks more like a shock, and we are not sure yet, but once we apply something like a three-dimensional reconstruction like GCS for using multiple data sets, as we now have Punch also for white light observations, so C2, Core 2, and Whisper, and also with Punch, we can specifically look at different parts of the CME, and we can get more refined 3D reconstruction of the CMEs. If you go to the next slide, yeah, so what we are actually seeing in Whisper is those three orange arrow marks on LASCO C2, C3 combined image. So that part is what we are seeing on the left side of Whisper image, but much further from LASCO. So if you see the outer boundary is 30 solar radii for C3, from Whisper, we are looking much into the heliosphere, starting from around 26 arson to 105 arson of the CMA propagation. So when we apply, once again, with the GCS, we can see how the CME propagates and also get different geometrical parameters of the CME, and obviously with the shock. Additional to this heliospheric point of view, in the next slide, Sarah, please. Yeah, so there are very good observations from radio and also microwave. So here, if you see the snapshot on the right is from OVRO LWA observations in megahertz of frequencies. So what we get essentially from those emission is the middle coronal emission of the CME. One moment, so let me see. I can't see my cursor. Okay, anyway. So with EOFSA, as Anna was pointing out, with the different bipolar structure in the active region and how different flares were erupted from each of those locations of the active region. So EOFSA, which is more in a higher frequency range or in the microwave range, can look more closer to the surface of the sun near the active region, whereas this LWA can look into the middle coronal region, which can once again complement with Punch observations and can look into the propagation of the CME and also its plasma parameters if we are doing spectral analysis type of examination. Yeah. So that's all from my side, Sarah.
Thank you, Shahi. That's great. I really appreciate it. But wow, this has been an excellent overview. I want to pull up one extra slide just because after seeing Bernie's, this kind of brought this to mind. This is the Gong potential field extrapolation for a few days leading up to the eruption. The eruption happens. And I just want to call your attention to the north-south orientation of the heliospheric current sheet that's so clear here. And there was that north-south density structure that he saw. So I think this is another kind of piece in the puzzle in terms of the large-scale streamer structure around these active regions that were erupting. Okay, well, we are right on time. I am going to just make two quick announcements, then we're going to take just a 5-minute break. And then we've got a real treat for you. Rafael Ate has put together a Python Jupyter Notebook that you can do online with no Python or download or anything. And this will enable you in future to make movies of Punch in a very powerful way. First, though, I want to call your attention. I think Craig mentioned it, but I want to remind you again that we are having a community briefing and office hour. So it's like what we're doing now, except we're going to be there in person, and you can come and talk one-on-one, and we can answer questions. So if you're in New Orleans for any reason that week of December 18th, for instance, going to the AGU, please come by. It's the Hotel Le Pavillon, which I'm going to send out again in announcement. More will be sent to the mailing list. And next, this is a big announcement, hot off the presses as of an hour ago. The abstract and registration are now open for our May 12th to 14th meeting in Boulder, Colorado. That's going to be a really exciting meeting. And shout out to Don Kalinsky for his absolutely beautiful logos he does for all of our meetings. This one is basically showing us the trefoil of Punch. So with that, I'm going to go to, you all should have seen you should have been able to get these slides from the chat. You can also go to this slide, okay? And we'll put this slide link directly in the chat as well. And so in the next 5 minutes while we take a break, if you don't feel like taking a break, if you want to get started, make sure quickly in 3 minutes, set yourself up with a Google account. Hopefully by now you have one because we did this last time. And then you can go to this notebook, which is what Raphael is going to walk you through. But you can make your own copy, and this will allow you to run it and save your data and have it for future references. So I'm going to leave this slide up for you to review. Please ask questions in the chat, and we're going to take 5 minutes. We'll be back in 5 minutes, and Raphael is going to lead us through making Punch movies using a Jupyter Notebook. So thank you, everybody, and we'll see you in 5 minutes.
You're on.
Hi, folks. We're about ready to get started, but before we do, let me just show you, if you've all done this, it should be pretty straightforward. You click on this, and you go over here and you say, File, save a copy in Drive, creating a copy, and then it should open that copy. If anybody has any questions about that very first step, put them in the chat. And you'll see that what we're going to be doing, I know some of you are going to be tempted to just run all, but we're going to try to do it one step at a time so that Raphael can really walk you through it, and then you can explore your wish.
So just because we have 63 people on the line, maybe you want to repeat that once, just so we're
I will
sure
repeat
nobody
that
falls
again.
behind.
Absolutely, and please put questions in the chat as you go. So again, you should see, in fact, I'm going to go to the chat. There is a link right here that you can follow, and inside that, there's a link that you can follow, and then you can go here to File, and you can do Save a Copy in Drive, and it should open up a copy. And we'll talk a little bit about how you can put that in a permanent directory. I can actually talk about that very briefly now, which is to say, if you go into your Google Drive, which is drive.google.com, and you go to My Drive, you should see, maybe not quite as many folders as me, but something that's yellow and says Collab Notebook. And that, by the way, is where the many versions that I've been copying of Raphael will automatically go. Later, Raphael's going to show you how to set up a directory called Punch Movies, which will allow you to save all of the data locally. Okay, Raphael, are you about ready to take over?
Hi, everyone. Yes, I am.
Okay, so then why don't you share your screen,
Yeah.
and I will go ahead and stop.
Okay. Sharing my screen. All right. Okay, do you all see my screen?
We did.
Okay. All right, everyone. Hi, so I'm Raphael Atier. I'm the mission co-I and also a working group lead for the working group 1A about tracking the solar wind flows. And today, for you, we made a tutorial for creating punch movies. We're going to start with basic installation of what we call the dependencies. Please don't get ahead of yourself. Please follow at my pace because we want to get this right at the beginning. So you will start by simply clicking on the little play button of that first cell. And yeah, please shout if I'm not clear and if you're lost. And we'll I'll re-explain things. So yeah, if I'm going too fast, please let me know. So when you do it, you may have a pop-up window. It's gonna, if you look at the comment there for a step-by-step explanation, if you get that pop-up window asking you to restart, please click Restart the session and run this first cell again. And the second time through is not as long. I'm seeing on the chat, Eric Bichelin is asking for a link to the notebook.
Okay. Yep. Could you
Yep.
share that?
Yeah,
link? I'll do that.
I'll paste that in.
And Raphael, I'm going to let you know on my end when I see the reset come up, so you get a sense of how long it takes for somebody who's running it semi-cold. It's still downloading. It takes a little while to download the first time you do it.
Yeah, that's okay. So I don't mind repeating as much as needed. So for those of you already there with me, so you can run the first time that cell. It's gonna ask you. You're gonna have a pop-up window. It's gonna ask you to restart the session. That is expected. Just click restart, and then run that cell again. And you should see, like me, all the requirement already satisfied. If you see at the end of that window a restart button, just ignore it.
And one thing, just Craig has put in the link directly to the collab, but it's better if you go to this Google Doc first because it tells you how you can actually save a copy before you start running it. You can just start running in Raphael's. It won't like mess him up, but it does have some issues that are described in that Google Drive. So it's preferable that you first make a copy to your local Google Drive, if that is clear. So that's why that Docs Google is the sort of the pre-step, which is the step 3, save a copy in Drive. And I'm going to tell you that I have now seen a thing pop up that says restart session. I think others have too. I'm clicking on restart session and it seems like it's fine. And so after I click on that, I'm going to go to that little arrow again, right, Raphael, and click that arrow one more time. Why don't you just model that?
That is correct.
So the
Yes.
pop-up said restart. I clicked on restart and then I clicked that arrow one more time and I'm already done because the next time
Yes.
through. And I did see a little thing embedded that said restarted, like inside the cell. Don't click that. Just click that arrow. So is that clear as mud? Yes, this is being recorded. So you can absolutely try this again, hitting pause.
Okay, if you're lost at that point, if you followed everything, but you're still lost and things are not working for some reason, that you get an error or anything, just notify us.
My second cell threw an error that it didn't have SunPy.
That is because probably you didn't run the very first cell properly. Can you try that again?
Yeah, you need to run the first cell before you run the second cell after
Yeah.
the restart. So
Yeah.
Rerun the first cell.
rerun the first cell.
Okay.
Running out, and then are we ready for the second cell yet, Raphael? Because it looks like Craig's jumping the gun here.
Sorry.
Yeah, SunPy is installed when Punchbowl is installed. So if you have an error saying that SunPy is not installed, it's because the first cell was not executed properly, and you may need sometimes to execute it twice. That's why we ask you to execute it again after the first round.
Are you ready for the second cell click, Raphael? You think?
Yeah, just making sure everybody has the first one. All right. Okay, the second cell, again, execute it and make sure you don't have any error.
And if you do have an error, try going back and do the first cell and then the second cell again.
Yeah. Oh, okay. All right, glad you're back, Craig. Second cell, good. Now we are defining another bunch of functions. It's simply a class that will help us download the data properly. So run that class definition. It should be instant. And you run it, once you have a little green check mark that shows you the execution time. It also should give you a number here as a cell number. We'll go through everything, and then I'll come back later to explain and answer questions on any question you have on what each of those code blocks do. So the next part is that we're gonna define the time range that we want for our event, as well as a data product code. And we had a brief intro from Marcus about different naming conventions and what are the data product codes. We're gonna work with level 3 CIM data. And so in that cell, we have already defined the start time and end time of the event. And because we're on a collab, we have a limited disk space. So we selected about a day of data, but we're not going to download the full cadence of the data. We're going to skip every 4 frames. This is what this skip parameter is. We have our product code, which is level 3 CIM. And then just click again on the play button. And we'll execute that cell. Make sure you don't have any error. If you have errors, please let us know. We'll come back later to this optional thing. It's all commented, so don't mind it for now. Now go to this cell that starts with a punch data downloader. Execute that. That one will take a few seconds. It's simply querying what data are available through the VSO. It doesn't download data yet at this point. It's just querying to check what data are there. And so you should see a result that tells you how many files were found. And in that class, we've put an extra filter to make sure that we are dealing with the level 3 CIM data.
And Raphael, we have a question about in the chat. Do you see it?
Yeah, it's going to be answered. That question about G or H is going to be answered right at the 2 cells below. So just wait a few seconds. I'll answer that. So now we are starting the download. So just click that. It's going to take some time depending on your bandwidth. It's downloading the data. And you may have a pop-up window on the left sidebar. Just close it. It's a bit distracting.
So that's the X. Click on the X to close it.
Yeah, don't confuse the X and the plus sign. There is an X, some sort of at the top right of that sidebar that pops up. Just close it, because otherwise it's going to be very confusing to navigate later.
And since it's still downloading, I can answer Craig. I think Craig asked the question about running out, and Chris, if you go back to later, if you look at those Google, the list, step 1, step 2, step 3, which was your entree into this, there are some footnotes. And on the second page, there's a footnote that says if you have your own local Python that can run notebooks that you prefer to use, you're welcome to do so. So you should have no problem, but let us know if you do.
Okay, so hopefully by now, well, I already had downloaded the data, so for me that was very quick. But for you guys,
yeah, we're done, at least on this end.
It may be for some, who if you're in a, I don't know, if you're using SpaceX Starlink internet, maybe slow, or so. Anyway, I hope everybody is there now. Everybody has the data, no errors. If there are any error, please let us know. And now I'm going to answer that question from Pritam Das about the goal for hotel data. So you simply list here what was downloaded in your output directory. And you can see here that what was downloaded was simply the version golf data. And here I'm only showing 4 samples. You can, of course, list the entirety of the files by doing what I'm doing now. And here you have the entirety of the files by simply asking to print the files. And you see it's only version golf. Now, it's a good question because I was wondering that myself. And so maybe Chris or Marcus can say if Fido and querying with Fido, does it by default simply query the latest available or not? That's a good question, because here I did not specifically ask for version golf. It just gave me just the golf data.
Do we have an answer to that? Do we know? Because if we go to the the H and the G, but
it has to do with indexing by the Virtual Solar Observatory, which hasn't indexed. The data are so new, they haven't been indexed yet.
Okay, but by the time people want to try this again with hotel data, maybe later today or tomorrow, they would be able to just run this as is, and it should, and just look at the cell to see if in fact it caught the H data. Is that correct?
I don't know how the VSO indexes, so.
Okay, so check back. We're gonna send some information if we can about that as soon as possible. In the meantime, we've got golf for this demo.
Is there a pending question here, or should I continue?
There's another question, yeah.
So yeah, it's the subsequent question. So can you answer whether, how much time it takes before we, once you have the hotel available after the golf one, how much time it takes to be available through that query? Do you have an
Just
answer
for
on
the
that?
sake of people kind of seeing what's happening, if they follow the link I just put in the chat, you're going to see that both G and H are currently sitting on the SDAC. So this will be cleared up. This is really hot off the presses. Generally, there's only one version that will be on there. Is that correct? There won't be an ambiguity.
For now, with this version 0 stuff, all the past versions are on the SDAC. I don't know if the VSO keeps them all indexed.
I don't know.
At the moment, G and H are sitting in this directory, but not anything else.
Yeah.
Just, yeah.
So yeah, if we have time later, I already made a code to download directly the hotel data, but only if we have time, we can cover that a little bit. And this is also what Chris is suggesting. So for the sake of time, I'm just going to continue. We're going to stick for now with the Gulf data, but everything you're doing now, once VSO has everything indexed, you can run that collab again, and the hotel data should be there. And the question is whether or not it's going to download both Gulf and hotel. In that case, you would need to make an extra filter once everything is downloaded to only get the hotel data. I'm happy to provide more support later if you need to have a way to not download everything, so that when you make a query with Fido, it only queries the hotel data. I just haven't started looking into that yet. Okay, so now we have, I'm going to hide that output because it's a bit distracting. All right. Now we're going to prepare the movie. So here there are just a bunch of little parameters for binning the data so that we don't display things at high resolution. We just don't have enough memory with the Colab to do that. And we're going to work with gamma scaling, sorry, power law to scale the color map of the data. So this is what those gamma and power law are doing. It's just for the visualization. This is not a scientific pre-processing of the data. So please run that. It's going to simply load the data from the fix file and rescale them with a gamma scaling function. It's going to get confusing.
We're just talking about the NATO alphabet.
Okay. All right, let me close the chat. I'm super distracting. I'm going to rely on you guys.
Yeah, we'll
Sorry. Okay. All right, it's still loading on my end. All right, it should take less than 30 seconds. And now we're gonna, hopefully it's gonna work for everyone, try to make a very cool interactive plot. So once you're there, please, the interactive plot, just run the thing, and it's gonna take a while to load. Please be patient. And during that time, if you have any error, please let us know on the chat. I'm not monitoring the chat now. Ugh, my coffee's cold. All right, it took me 20 seconds. That's great. Now if you go to the bottom, fingers crossed. Yeah, okay, it's working on my end. You should see that. An interface where you can interact with the sliders so that you can actually explore the full depth, I mean, almost the full depth of those great imagery. And so if you move the sliders, you can then change the scaling of your data, the intensity scaling on both ends. So it's a little bit subtle, and the default value were given to me by people who are more experts than me to visualize CMEs. So the default value that you should all have are 1 to minus 14, and for the minimum value, 1 to minus 12, the maximum scaling value. And what's also very cool is that you explore the timeline, the time series of your data. So when you move the slider, you're going to see the time series. And you have also the data. And remember, we skipped, we're displaying frames every 4 frames. So every 4 frames, the trefoil pattern comes back roughly to the same place. Not exactly, so this is why you have a little bit of a drift. But if you do it at full resolution, at full cadence, without skipping any frame, it may be a bit distracting in the current version. So this is why we've been also skipping the data so that you can also see a longer duration of the event without saturating the memory. Okay, I hope everybody is there. Let me go into chat, because that one I really want everyone to be able to display that. Okay, I see in the chat some explanation of the power law. Thanks for that. because I had actually the same question. Why 2.2? All right. Excellent. Excellent. I'm glad. I'm glad. So I'm just gonna pause here, let you play with that a little bit. Play with the sliders. Maybe ask questions. Take your time exploring the the vmean, the vmax, the image index. I'll give it a minute, and then we'll continue for generating the frames.
And Craig or Marcus, maybe you can comment that this is golf and we will get hotel up. The difference we expect to see when we run the same notebook, but with the new H hotel data. Can you say again what we expect it to look like? Just much more contrast, right?
There will be more contrast because the F corona will be better subtracted. And if you scroll frame to frame through the generated movie, you'll see that you can tell which Wi-Fi is which by how they go around. It'll be much harder to tell with the hotel data because the vignetting functions are better.
So the transition from one part of the trefoil to the other in particular.
Yep.
There's an interesting comment from Anna. Can Anna speak up to explain what she has in mind?
Oh, I'm just enjoying the little interactive thing that you made with the minimum and maximum sliders and the image index. And one more cool slider to potentially add would be a vignette.
So I spent hours trying to do that. The thing is, as you could see earlier, because I've got a functionality in my own software that is running on local computer. For the Colab, it's not possible because I'm using a JavaScript code, and JavaScript doesn't support very well gamma scaling color map. In fact, it doesn't support it at all. So this is why earlier, and I thank you, Rui, for asking that question because I really spent hours on that. This is why I pre-computed with a given gamma value. And if we were to have a slider with an update on the gamma value, we would be each time we're generating a frame that's pre-computed with a gamma value instead of touching the color bar. Normally, the right way to do that is to have just the color bar, the color mapping change, not the data themselves. But that's not supported by the framework I'm using. That's the big limitation of this interactive GUI.
Gotcha. Then maybe then another idea is to pre-compute several powers, and I don't mean gamma power. I mean r to the power of something, like r to the power of 1, r to the power of 2.
Oh, you mean a radial filter?
Yeah.
Oh, yeah. In that case, that would actually not be about changing color map. It's going to be a true processing of the data, and then what I say still stands, even more so, because then when you're going to play with that, you're going to need to reprocess the entirety of your data, which won't be very interactive because it's going to be very, very slow to update each time. Do you see what I mean?
Gotcha.
Because it's still, if we pre-compute everything, you still need to load that up in memory. And for the sake of Colab, well, we only have 12 gigs of RAM in there. And so you're going to very quickly saturate the RAM.
I got you.
But I think all sorts of tools like this are being developed, and we encourage people online to develop and use the GitHub. Is that what you just said?
I'm going to post a link to it. We have a bit of code in Punchbowl that can do this.
Yeah.
So I'll post that in.
So we have a GitHub to work on these things. So shall we go on to the next, the movie generation?
Okay. So what's happening next is that you should basically use that configurator with the GUI to make sure that you're happy with the scaling values, because this is just to help you create the visualization that you prefer to create then the movies. And so the next step is going to be generating the individual PNG files that's going to be given to the movie creation. We are using FFmpeg. It's already installed in this Colab environment. So if you click there, take that back, make sure you enter your preferred scaling values that you have determined after playing with the sliders from the GUI. So once you're happy, you simply read out the vmean and the vmax, and you put them back here. And here by default, we have those two numbers that we on our end preferred. But if you have your own different preference, just enter those. And once you've done that, simply click Run. And to take again a split second, it simply just display the static plot that wraps up everything we've set up so far. That's going to be what the PNG file, the individual PNG frame is going to look like. So if you're happy with that, you check that the visualization is what you expected, then go on and click on the next block. That will generate the PNG frames off the screen. You will not see an output here, but there will be configured just like it's been previewed right before. That one should take, that's the one that should take less than about 30 seconds. I was getting ahead of myself before. So here, we have entered the preferred scaling values. You have a last preview of what the PNG file is going to look like. And then we run the code that generate the PNG files off the screen. And they are saving that into your the space, the disk space of this Colab. And so, okay, in my case, it took longer than usual, 50 seconds. And so again, there is no graphical output here, simply a summary of how many frames were processed. You know everything went well if you have that last line that tells you that it finished processing. It tells you how many frames it processed. So you should have 45 frames at that point. And the last bit will be simply to create the movie itself. By default, we are creating movies with this name convention: punch movie, the start time, the end time, and the product code, which will be in here, ELS3CIM. You can play, of course, with those two parameters, this frame rate that will determine the duration of the movie, how fast the imagery will go. You can do a bit of cropping if you wish to eliminate white bands around the movie. Once you're happy with all of that, just click Run, and that should take just a few seconds. All right. Once it's done, you should have a prompt, a print here that tells you that the movie were created. Remind you where the movie is. This is the name of the file, and to get your file and download it back in your computer, you go on the sidebar, you click on the folder icon, and here you should see your movie file. Click on the little three dots, click Download, and you should have your movie. I have used also, I'll let you play the movie, and the movie have a little filter that will reduce eye strain to smooth the transition between frames to make them less sort of epileptic. And so this is what this min-interpolate filter is doing. If you ever use FFmpeg yourself in the terminal, you may be more used to that. I highly recommend that you use that with punch movies because it makes the preview much more agreeable to the eye, especially given that we are trying to keep the movie slow enough so that you can see the evolution of the CMEs. So this is why I chose 10 frames per second. To me, that was a good compromise. But if you don't use the filter that I put there, things can get a little bit choppy, and it can be tiring for the eyes. Because this is what this min-interpolate blend mode does. It smoothens things by creating temporal interpolated frame. They're linearly interpolated in the time dimension. And the FPS 60, it's simply to have a 60 Hertz refresh rate of those. And so it creates as many intermediate frames as needed, where each interpolated frame is come from a temporal linear interpolation. All right, so I hope you're already, this time you already have your movies.
First, let me give you a question. It looks really good. If people could put +1 if they were able to get their movie and download it, do -1 if you couldn't. You have a question here from Pritam, who says, "Sorry if I missed it, but I see some jitter in the movie. What might be the cause? The 4-step jump? Question mark. Do we think that's it, or is it something else?"
Let me see myself. I got so used to those movies that the jitter could be, I mean, I'll let Craig answer that. You know, there's this triangle pattern that's sort of jitterish. That's the only jitter I see, but if you mask your own hand that triangle, you can see that there is no jitter in the star field or in the CME themselves. So it can be, you know, the triangle, when it turns around, can be a little bit distracting. To me, that's what seems to be jitterish. But I don't think what's around the features are being jittered. I think the alignment is great.
Yeah, the alignment to my eye looks good, but there's flicker that's going on because of the vignetting function in the Gulf data.
Yeah, so I guess in the hotel data it should be less conspicuous.
And I think some in the borders of the Wi-Fi fields of view, you see them kind of oscillating, kind of breathing in and out. And I think it's from this min-terminate filter that Raphael put in to make it less jarring.
Yeah, it's even worse. The thing is, yeah, if you don't do the interpolate thing, it's actually even worse. It's jitterish effect. But yeah, it is true that there's a little bit of ghosting on the edges due to the interpolate thing.
Maybe another effect that you might be seeing as jitter, Pratam, is the stars seem to twinkle in mine. And I think that's the subsampling, because the stars are gradually moving across the heliocentric frame, and so they go in between sampled pixels and then come into another sample pixel.
Yeah. You know, if you rerun that collage yourself later, feel free to compare to the version of the movies with and without the interpolate. You can simply comment that line and run the thing again. And just compare the two movies. You know, for some reason you may prefer the one that is not interpolated.
And also, if I think we have time to go back and do the local install, right? So that they can have more data and use their own memory. And the benefit of that is you can stop with the skip. You can make it a higher time resolution, and you could also see how that compares.
Absolutely.
Should we do that now, or should we do that last?
Sure. Yeah, we can do that now. That's up to you guys.
Or do you want to do the running difference first? Which one do you want to do first, Raphael?
Let's do let's do the running difference first. Okay, so the running difference images is something that you may want to be interested in doing. We're going to follow the same workflow. We're going to simply pre-compute the difference images. So you would click that new code block. And it's a running difference, not a base difference. The reason I chose that is because the base difference has too much imprint from the first trefoil pattern. And doing it as a running difference is just a little bit less distracting.
But as we get to Hotel India, that improved data, a base difference becomes much more useful, right?
Yeah, exactly. Yeah. Okay, now same business here. Made you a GUI. So let's run that. I realized that there is a misleading comment here. I will remove that. There is no power law involved with the running difference. We are using a linear color mapping, as you can see here in the highlighted code. So I already removed that comment. All right, so let's see what we have down. down below. Okay, that's working on my end. I hope it's working on your end. If not, let us know. And there again, you can play with the time and the scaling. By default, I've chosen a symmetric scaling with negative value and positive values that are equal in absolute value. But we can stretch that on both ends. So now I'm going back to an absolute value of 3 to minus 13. Let's see what it does. Get a bit of a higher contrast. And then you can scroll it a little bit. And I'm seeing some interesting structures here at the top of the triangle that propagate upward.
If somebody gets like what they think is the ideal levels, put them in the chat. I have some I like, but.
And yeah, and the reason also I wanted to offer that flexibility is that there is huge variation from display to display. It's crazy how things can get visible from one screen and not visible from to another screen for the exact same parameters. And yeah, so that's why I feel free to do not necessarily take my default value as the absolute must do. I'm actually not very experienced at visualizing CMEs. So go with what is most visible to you.
I went back and forth and ended up on exactly what you have. But other people may find something else. It also depends on what you're looking at, right? I mean, sometimes if you're trying to look at a particular feature, you really want to choose something that emphasizes it more.
Okay. So I'll let you play a bit more. I must admit that it takes more time to narrow down things on that one. It's not super easy, and it can be a rabbit hole to really nail down, because you can look fine in one frame at a given time index, but then later on you realize that, oh no, you want to change your values. So yeah, it's a bit of a black art. Okay, so on the next code block, it's the same workflow as before, where you enter the values of the Vman and Vmax and Vmin that you decided. In my case, and you can change that, in my case, I need to make sure that I have a symmetric sort of color map centered around gray. And so this is why I only enter my Vmax, and I keep my Vmin just being the minus of Vmax. I was told by another expert that it's usually what CME folks do. But if for any reason that, we just screen and your eye, you feel things differently, feel free to put an actual different value there. That's not a function of Vmax. So once you've decided on that, once you've converged, you will click, and it's simply, that one is simply summarizing your input and showing you what the PNG frames will look like. And already here, maybe Craig can comment on the little ringing features there. I think he mentioned that earlier as one of the differences between version golf and version hotel. I don't know if that those arcs will disappear with a version hotel. You see what I mean, Craig?
Yep, that's exactly right. We actually issued a nugget on that a little while ago about the square root coding preserves the mean. We worked very hard to make that happen, but also messes up some of the higher order statistical moments of the distribution, which means that our background subtraction gets a stair step in it. So in the hotel, we're reconstituting the photon noise. It doesn't matter what photon noise it is, as long as it has the right statistics. So we just add back in our own on the ground. I like to call it, it's like orange juice, right? If it's reconstituted, it doesn't taste like the original, but it's good enough.
Okay. So once you've dialed in your preferred value in that block, then you're ready to move on to create your PNG frames. Let me check that everything looks good for me. Yeah. All right. So click run. By default, it goes in the same directory as the other PNG frames. But if I didn't mess things up, the movie will recognize different file names. So I've inserted in the file name this diff suffix. So we should be okay. You should be able to live with both versions of the frames in the same folder. But again, you have the code. Feel free to modify that. This is not the Bible. Okay, so it should take, again, less than a minute to generate everything. It's just 45 frames, but you can see it's pretty slow, right? So this is why, again, if you go full resolution, full cadence, everything, even from your local computer, it could get slow. In the future, I might work actually on a parallelized version that create those frames in parallel. That should be much faster.
Raphael, can you show them the memory, that tab? I think it's in.
Sure. Yep. Yeah, this part is quite decent regarding the RAM. And for the disk space, remember that on Colab, by default, you only have barely 60, 70 gigs available. And so that's why if you start having long time range, full resolution, full cadence, they can fill up quickly. And so we'll come to that on how you can still use the Colab with more persistent data on your own Google Drive folder, so that you're not limited by 100 gigs, but will be limited by whatever you have in your Google Drive. Okay, so once you've got your frame processed, same business. Click here. It's going to generate the movie. All right, and you will find your movie. Click on the parent directory of this notebook. So if you open the folder icon, look for the punch diff movie and download that and take a look. And I'm going to go back up to my GUI. I just wanted to make a comment that I think is important regarding the GUI. You may be tempted to use little tools on the right. I don't think it's much useful unless you really have impaired eyesight. But the image that is displayed there was already downsampled by a factor of 8. So you will not get much detail if you zoom in. And I want to stress that this doesn't reflect the true resolution of the data. The image you download is 4K by 4K. But with a GUI, we're working with an image that is 512 by 512. So you will not access to a higher level of detail if you use the zoom function here. Another comment, I didn't have the time to uniformize my axis coordinates. So in the GUI, I am using apparent distance in solar radii, using a range that I saw from another presentation. So this is not super accurate. However, the PNG frames that you export and the movie that you get in the end are using the accurate WCS data of the metadata from the feed files. So the PNG frames have a much more accurate coordinate system than the GUI. Okay. Can we get a +1 for everyone who managed to got the movie of the running difference? Just so an idea of where everybody is. Okay. All right. Excellent. -1 for people who who's struggling and had some error. Thank you, Eric, for the thumb up. All right. So now it's 12:50. I have only 10 minutes, right, Sarah? Or
Yep, I think yep, and you should have time to go back and do that last little bit, I think.
what did I? What? Sorry, can you say that again?
Yeah, going back to that part about getting local files, I think will be useful for people.
Yes. All right. Yeah, that's what my intent. Okay. So now I'm gonna go back to a slide. It's not a slide. Sorry, a cell that was entirely commented, which is that one. It's an optional thing to have persistence of everything that you do in the Colab to be then hosted in your personal Google Drive. And because what you're doing now, all those files that you're outputting here, those punch movies, the punch data, the PNG frames, it is in a temporary space set up by your the current session of Google Colab. But if you're on the free tier, in a few hours from now, maybe even less, you're going to lose all of that. That is very temporary, and you will even lose what you've installed right at the beginning. You would have to do that again. And so everything basically is gone. Everything that's in the RAM is gone. So if you come back tomorrow and you run that again, you will have to do everything again. You will have to download those feeds files again, etc. It's not anywhere in your local computer. So we've done a little thingy there so that you have persistence of all the data that you're generating. And if you want that, then you need to have a Google Drive. You need to really have a Google account with a Google Drive, personal Google Drive. And you should just uncomment those 4 lines. And what that's going to do is, and we're going to execute that now, it should ask you if you want to connect your personal Google Drive. So you get this window and just click on connect to Google Drive. And there, and this is where it can get tricky, make sure you maximize a little bit that window. Otherwise, you may not see some continue button. And select your Google account. And here, click continue. And sometimes for some of you, that window can get too small, and you may not see the continue button. And so that would actually trap you in an endless loop, trying to find that button by re-clicking on your name there. So click the continue button after you've maximized a little bit that window. And again, in my case, I had already given those access, so it may look different for you. If you've never done it, you need to check.
Sorry, Raphael, I think that you cannot see your screen because I think you're just sharing the window, not the whole screen.
Oh dear. Thank you, Valmir, for that.
And while he's doing that, if anybody has had I got a crash because I didn't do, Valmir does a trick to delete all leading spaces when he does remove the comment. If you just like backspace over the number sign, there'll be another leading space and it will crash. So there are 2 leading spaces there you need to delete. So if anybody has that happen, that's why.
Yeah, I'll just illustrate what Sarah was just saying. So I'm gonna go back to how it was. Right, when you have those comments there, there's a leading space there. So if you delete manually the comment sign, it will leave a leading space. So this is what you need to. This is what can give you a crash. A good habit to have if you're not an experienced developer is when you have a block that has comments like that. If you want to remove those comments and remove all those leading space, hit Command/ if you're on a Mac, or Control/, and that will uncomment things, removing the leading space. And I see Gili gave that tip as well in the chat, and it is control / for PC. I just wrote it in the chat as well. So I have a mount fail because probably I waited too long. So I'm just kind of, I guess probably I will have to do it again. Let's see. Yep. Let's do that again. Do I have a pop-up there? Okay, it's working now. Once you've, unless you had an error, you should have this little text telling you that it is mounted at the /contents.drive. And you can double check that by clicking on the folder icon. And now you should see a folder that's called drive. And there you should have access to the entire content of your Google Drive folder. Now, we have updated already, at that point, the output directory where everything is going. So you shouldn't need to change anything at that point. Everything is going to go to the parent directory of your Google Drive. And if you followed Sarah's slide, there are also some advice on how to prepare for this Google Drive thing by creating a folder that would be, for example, here, Punch Movies, under your personal drives, collab notebooks directory. And because I'm showing my
Raphael, yeah, could you actually show that slide? I think that would be useful.
the slide. Okay, yeah, I was going to bring it up. Yeah.
Yeah, just to show them, because that is important to
yes.
the naming convention. So it's the second one of these.
The second one? All right. So in Sarah's slide, and you know what? I'm going to also make sure that everybody is on the same page. I'm going to resend the link to that slide in the chat. And so you go to the second slide, you have these instructions to save things to your personal Google Drive. And let me actually bring that on the half of my screen. We have 2 minutes to go. And so you can see here on the collab, in the window, in the sidebar, the content of your drive. And so I'm going to go to the folder now where things would be going. It would go to the collab notebooks directory under the directory that Sarah asks you to create in that slide, which is Punch Movies. And so on the sidebar, then you can make sure whether or not you've created a directory. And if you haven't, then you should be creating it in your drive. So now I'm scrolling through my own content of my drive. So you're seeing my life. And I don't have a Punch Movies directory because I'm not running things locally with the collab.
Notebooks. It's collab notebooks. You have to start with that, I believe.
Yep.
So you need to go by alphabetical start.
Oh yeah, right. Collab notebooks. Forgot about that. So yeah, collab notebooks.
There.
I have one, and but I haven't created the directory that Sarah told us to create because I'm actually not using that solution because I'm running things locally on my computer. I'm not using collab for my personal dev. So yeah, this is how you can check that you did things properly, and then if you did and you run that again, then all your data, output data, will go under that collab notebooks directory tree. It is 12:59. I am done. I can answer questions maybe, or you guys can comment.
Yeah, we'll stay online for just a minute or two for some questions. But I just want to thank you so much, Raphael. This is really, really helpful. And you will be updating this probably a little bit more. So by the time I'll wait to send the email pointing people with all the links and telling them about where to find this recording and files for a day or two until we're sure we have something ready, Raphael, and then that way they won't have to make a copy again. We'll say this is the new, I mean, it is ready, but we'll put in something for the version, make sure H is in there and stuff. But that was really helpful. Okay, anything last minute, Craig?
I'm just going to echo the things that are coming up in the chat here, which is this is extraordinarily valuable. Walking us all by the nose through this process, showing the code patterns that are required is really helpful. So I hope others have found it as useful as I have. I've been making punch movies of my own notebooks, but I still found this to be a useful thing to do. So really much appreciated.
Thank you very much. I really appreciate it, and it was a real pleasure to show this this work. Thank you also to the SOC as well that has been also working around the clock on that and answering my questions at light speed. Thank you also to those who could not attend. They gave me as much information as possible, and bear with us also during this government shutdown. We are running a bit understaffed at the moment, so that's why we may not have covered everything you wanted us to cover. So bear with us on that. But we're dedicated, and I look forward to showing you more. And look forward to seeing the new data.
And I just want to also just thank again the people who gave the presentations at the beginning. That was fabulous. Craig, you have last word?
I want to put a fine point on the dedication of the SOC team that they really have been working around the clock. Chris Lauder has been working on the PSF. Derek has been working on a number of things, one of which is the cosmic ray reduction. We have Ritesh, who's in India right now, did a lot of the polarization work. Sam, of course, has been pulling out the stops. Marcus Hughes has been band leading and doing a great job of it. As a sign of the dedication, I have some chat logs from 11:30 last night, and people chimed into our local chat server, and everybody responded instantly. So anyway, thank you guys for pulling this particular rabbit out of this particular hat just in time.
Okay, I'm going to stop the recording. Oh,
And thank you to Sarah for organizing so well.